Hello my people, back again with another question, and this question is another Pigeonhole Principle question. So if you haven't watched my first video, go and watch that, which explains what the Pigeonhole Principle actually is and when it's used. So we're presented with a question that says, given any set of 10 integers, show that there exist 2 integers in the set whose difference is divisible by 9. Right, with a question like this, the first thing my mind would run to is, where the hell do I even start? Well, let's just start picking out key information from this question. 10 integers, and the difference of 2 of them is divisible by 9. Now notice here, we've got 10 equals 9 plus 1. Now this is a fact that you've known for years, since the age of 4 or 5, wherever. But why is this useful here? Now the pigeonhole involves an idea the pigeonhole principle involves an idea where you've got a surplus of objects that you are trying to arrange into a number of boxes. Again, if you don't know what that means, go back to my last video. But yeah, we've got 10 integers, and we need to show that the difference of 2 of them is divisible by 9. So somehow we're going to be sorting 10 integers within 9 boxes. Now what these 9 boxes are for us to uncover. So let's think, we're talking about divisibility by 9. Now if we say a number is a multiple of 9, we say it's 9k. How does 9k help us here? Now note, when we work with modular arithmetic, why is this relevant here? Because we're doing divisibility by 9. We usually work with residue classes. Now the residue class of mod 9, why mod 9, divisible by 9, is the following: 9k plus 0, which is just 9k, 9k plus 1, 9k plus 2, up until 9k plus 8. Now this is a list of 9 integers. And why is that useful here? Well, this covers 9k plus 0, 9k plus 1, up to 9k plus 8. Any number can be written with one of these forms, whether it's 9k plus 0, 9k plus 1, 9k plus 2, 9k plus 8. Test it for yourself. 27 is written in the form 9k plus 0. 32, 9k plus 5. Minus 1 is 9k plus 8, and so on and so forth. So let's make the link now between our pigeonhole idea and this modular arithmetic idea. So let's start sorting 9k and this residue and the rest of the residue class into these boxes. 9k plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8. Like I mentioned, this set of 10 integers, each integer must satisfy one of these conditions. So we can say for certainty that amongst those 10 integers, one is 9k plus 0. So let's write this in red, Italian red. Yes, I was saying we're going to tally in red. Where's that red? So we've got. So yeah, why are we tallying? Because we're just trying to sort our 10 integers into these 9 groups, and we know we're going to have a surplus of 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1. We've sorted 9 out of the 10. What do we do with the last integer? Well, we can't just leave it to the side here. It's going to obviously have to go in one of these boxes. Which boxes go in? I really couldn't care. It honestly can go in whatever. But if it goes, let's say, into the first one, right? Now we have 2 numbers of the form 9k plus 0. Note that the k value from here, from box to box, is different, because it can be 9k. So if just say k was 1, you're saying that we're saying that this number must be 0, this number must be 1. Well, we can have k as 1 here, or k as 2 here. Honestly, this will still be okay with the questions conditions. So back to what I was saying, we've got two numbers that are multiple of 9. Now if we subtract them, we know the numbers of the same numbers that are congruent to each other, when you subtract them from each other, mod n, you'll find that the difference is congruent to 0. So let's just show this, nk plus 0. So nk minus nj, for argument's sake. And then we're working mod 9. Well, simply, we can just factor out 9, k minus j. So rather than mod 7, mod 9. And since we know that this term here is divisible by 9, we can say it's congruent to 0. And that has shown that the difference between this specific term here is divisible by 9. Now, so we've just taken a general case. Sorry, we've taken a very specific case. Let's move on to a more generic case, where we have nk plus n and nj plus n. So that can mean any one of these 9 boxes. So nk plus n minus nj plus n. So we're working in the same mod class, so we're working within this box, or this box, or this box, except the multiple of 9, k and j, is different. Let's write this where k is not equal to j. Now we're working mod 9, so let's write mod 9. So if we simplify this, we have nk minus nj, and now we're just left with an expression similar to our specific case. Factorize an n, k minus j. We factorize the, sorry, not n, 9, I always get mixed up with the 2. We know that 9 times k minus j is indeed a multiple of 9. So that means it is congruent to 0 mod 9. And that's been, by doing this, we've shown that for every residue class, our question's condition is satisfied. Any two integers, any class, the difference is a multiple of 9. Nice. And that is our question done. This one's a bit short, but hey ho, we had fun. Yeah, please continue to watch my channel, because I guarantee you there'll be more of these Pigeonhole Principle sort of ideas. I think the thing is with Pigeonhole, right? Everyone knows how to use it, but if you don't know that you have to use a Pigeonhole, it's the fact that, do you make the link that yes, this is the idea I need to use for this question? I think that's what really separates a mathematician to a phenomenal mathematician. So enough of my app. See you next week, or next video.